Okay, look at that. The last topic is easy because it's about the inequality and system of inequality in two dimensions. Now we have one inequality or two inequality or three inequality or four inequality. You have a system or only one. I want to explain only one now. I know that you know very well this because I teach in this in intermediate algebra. But I want to recall, no, in order to introduce the terminology, the symbolic way to indicate the solution, etc. We have first of all this inequality, super easy, example 1, 3x minus 2y less than 6. Es obvio that the solution of this is a region, and this region you need to shape in the rectangular coordinate system. O sea, the solution, bueno, you can express analytically, pero no. So basically, is solution is graphically. Of course, we are using decimals to make any graph. And remember, in the test, you make a copy of this graphic that you are doing and attach with the test. Okay, so let's do it. To solve that, the first thing that you should do is solve for y. Minus 2y less than minus 3x. I'm moving 3x to the right hand side with the negative sign plus 6 divided by negative 2 because my goal is solve for y. So we have y because negative 2 and positive 2 division is positive 1. So we have here 3/2 positive. Again, negative divided by negative positive. And positive divided by negative is negative 3. And don't forget, important, okay, when you manipulate the inequality and you multiply or divide by negative number, in this case was negative 2, the sign of the inequality is reversed, flip it. Okay, super. Now, immediately, this is my new inequality, by the way, is 100% equivalent.
Professor. It's reversed because you divided by a negative?
Yeah. If you divide by positive meter, it stays the same. So when you multiply or divide by negative number minus, you reverse it. You flip it, switch it, the sign. When you multiply or divide by positive, no, it stays the same. This idea is clear for everyone? Reverse it. Reverse it who? Reverse the sign. See, original is less than, you permutation to the greater than. See, the original side, you swap this. Así es equal. This idea is clear? So there are two reasons in algebra in which you have to permutation or you have to reverse it, the sign and the inequality. Reason number one, divide and multiply by negative number, that was this example. Or for some reason is you interchange, suppose 5 greater than 4. This statement is super true. However, if you interchange, you put a 4 here and a 5 here, you have to reverse. Similar situation, if you multiply by negative 1, suppose you multiply by negative 1 here, and by negative 1, or by negative 2, or by negative whatever, is negative 5 and negative 4, but now the symbol is less than, no? Because negative 5 is less than negative 4, no? This idea is clear, guys? However, if you multiply by positive, no, stay the same. Cool? Okay, now, temporary to understand much better the solution, you transform it, no, write this inequality like equation. Why? What's the reason? Because I am super familiar with the graphic of the equation, and the equation allow me to split the plane xy in two semi-plane, and now I need to make a decision if, well, see, the solution is above the line or below. The convention is, you're doing the line, okay, no problem, it's easy. I compare with the y equal mx plus b, you are super familiar. and b is -3, que b is always the y-intercept. I plot that. This point would be 0, -3. I plot that. And from this point, you moving according to the slope. Okay, slope is 3/2. You moving slow is always the ratio between two numbers, right and wrong. As I see clear, the right is +3 and wrong is +2. So from this point, I'm moving 3/1, 2, 3, and 2 to the right. And you plot the second point is 2, 0. And you are ready now to connecting this point with the straight line. Now, what is the challenge? Or the symbolic way? We have two kinds of line. We have the solid line or dotted line. What is the difference between solid and dotted? Well, dotted or whatever, solid, solid line is when you have in my problem less than or equal or greater than or equal. So when you create equal, you put solid. And dotted or dashed, whatever you want to call line, is when you have less than or greater than without equal sign, because that indicates that the line is not included inside the solution. Okay, now my problem have no equal sign, so I know that the line I need to do is dotted line. Okay, do the line. Okay, this line allow me make a partition of the plane XY and two semi-plane. The plane above the line, or below the line. Depending on what gets below or above. Oh, depending on the sign. Si es greater than, it's obvious above. It's bigger. Si es less than, it's below. Pero not always, guys, because remember, here you see less than. But the problem is that this is confusing because in this equation, the original given equation, the y is not isolated. So I don't care this idea. I care this idea when the y is isolated. AC is greater than. Therefore, the solution set, the solution region is the region above the line. So I'm using one color to highlight. I don't know, I select green color. Let me try, and you shade up. Of course, we are doing now an elegant way using decimals. But I want to dedicate at least the most elementary first example to explain the basic idea. After we are doing in decimals because we dedicate not always and only one nice inequality. You know, we have a complicated example that we have several inequalities. Entonces, a little bit confusing by hand. See the solution region. So actually, any point on this region, for example, I pick one arbitrary. This point, bang, a solution. This point, bang, a solution. This point, bang, a solution. Okay, entonces in this case, 2,3. Well, one elementary trivial example is you plug in this into the regional and verification is true statement. Let's do it. So it says 3 times 2 gets x value minus 2 times 3 should be less than 6. This is my supposition. This is 6 minus 6 is 0 and 0 is less than 6. Oh, it's true. So you select one guy outside and you plug in, obviously it's not true, it's false. Clear? Super clear or super confused?
It's clear.
I want to show you what is the way to do in decimals. Okay, let me try to share. I don't like this. Okay.
Oh, so test.
Go ahead. Question.
To determine which side is the correct side, we have to test. We have to test a point.
Yeah. There are many ways. There are many ways to do this. One possibility is, do you see now the whiteboard, right? Yeah, mister?
Yes.
Yeah. Remember, we have 50-50. 50% you have in the green region. I am confusing about what? Okay, I want to clarify. 50% you are inside the green, and 50% you have in the white color. I know, coloriate. Now, one possibility is using this idea. So you know that the sign of the inequality is greater than, look at that. Look at that. After the isolate y value, entonces es obvio que es above, and you shade above. Sometimes, well, sometimes it's not trivial, sometimes it's more complicated. And one possibility is you pick one arbitrary testing point inside. For example, I pick this, remember, right? Yeah, I plug it in, I get true statement. Wow, fantastic. Suppose you pick another in the wrong region, suppose this guy, que es 2, -4, no? 2, -4. 2, -4. And you plug it in the region is 3 times 2, again, minus 2 times -4. Should be less than 6. This is 6, but it's a plus 8. Entonces it's a 14. And 14 is less than 6. No, this is false. And you discard what is the region that is correct. Do you understand very well or no? Yes or no? Say something, no? You ask me, entonces I expect your answer, no? A ver. Okay, so let's move into Desmos. No answer, no? Definitely. All right. I'll rewatch the video. What video? What video you talk about? Rewatch the video. Well, why? You understand right now? See, it's elementary idea. The one being recording. But what you need to rewatching to understand? You don't understand right now. Hey, miss. Let me try. Let me try my best. 3 dotted points. Yeah. Okay, let me switch into the Desmos view or screen window. Sorry. Okay. Do you see my Desmos? Do you see my Desmos? Yes or no? Oh no. Yeah, Johnny says no. And the other students, no? No, not yet. A ver, let me see. Alice dice no. Okay, Alice. Let me try one more time. Now, image. Okay. Yes. You see now? Wow, they are so delayed. So I suppose everyone saw that? Well, doesn't look. Giselle. Okay, Giselle. Yeah, that's it. I understand. The example one was you need to switch it to the speaker view. Speaker view. Okay. Speaker view. Speaker view. Okay. Speaker view. Okay. Look. I copy in the real life. Nobody is doing in the piece of paper. Everyone is doing on Desmos. So now you copy the original inequality, exactly the same is given, no modification, no isolate, nothing, and you activate that. Bam! And you see que in that the blue color is the solution of this. If you want to put in the same color, okay, put in the whiteboard, you press this, you press the left click of the mouse and you select the color you prefer, green color. And this is the image I want to see on the test. Cool? Cool? Everyone follow me? Yes, Kiana. Okay, let's move on to example 2. Example 2, I want to complicate a little bit your life. Example 2 is non-linear. So example 2 is x squared plus y squared less than or equal 4. Now you focus it. X squared plus y squared equal 4 is a circle. Yes or no? It's a circle. I suppose you remember that formula because it's called algebra, no? It's a circle, and this circle, the center is located at the point 0, 0. Hello, sir. I am sorry. Notice my name is still showing. Well, hello, I am sorry. It is Kegan. Kegan, pero you participate or no in the meeting? Oh, let me see Kegan. Kegan is a student very complicated. Everyone understand very well. No. You are not here. I don't understand why. You have some problem with the computer, internet. This is a moment that you make a decision that this class is not for you. Because to take class online, you need good condition. You need good internet connection, good computer or laptop. Without this, no online. Go to the classroom. Next semester, you take with me again the class. Okay? Yeah, no more interruption, guys. Please. Okay. Let's move into Desmos. Do you see Desmos very well, no? Everyone saw Desmos very well now? You see or no? You are seeing? Okay, cool. Entonces, Yasmin, de La Paz, look. We are doing the example 2. The example 2 is non-linear. X squared plus y squared less than or equal to 4. Wow. Entonces, I realize, because my knowledge of the Cole algebra, que this look like circle. And this circle, the center is located at the point 0, 0, and the radius 2, que is square root 4. Do you see? Entonces my question is, entonces we are doing a circle, but we are doing the circle using solid line or dotted line. What do you think? Hello. My question is solid line or dotted line? No idea. Nobody understand anything. Wow, solid. You say it's solid because equal sign is solid. Okay, this is my first question. Good. My second question is, you shape in color outside the circle or inside the circle? Because now it's no line get split into semi-plane. No. It's a circle. It's a ball. No ball. It's circle. It's flat. It's 2D. And you put it the border of the circle in solid line. Cool. And now this is a moment to shape inside the circle or outside. Inside. You have 50%. What do you think? Outside or inside? Come on, opinion. No, only Giselle. Another Rebecca. A ver. Outside. Jenny says outside. Everyone is agree with the Jenny say gets outside the circle? No idea? Richard? Outside or inside? No idea. Say something. No, I don't know. Benjamin. I don't know. Okay. So say you guessing, no? But you're guessing wrong because it's inside. How do you know que it's inside? Let me show you. Desmo is fantastic. Demo, very well known algebra. Bang, it's a circle. And you shape in that color inside because it's less than and less than. So equal sign is in the boundary. We have two colors. A purple color is one region and white color is another, right? Any point inside. For example, excellent testing point, 0,0. Okay, let me try. 0,0 is the origin, no? 0,0. Suppose I have totally lost. I put 0,0. 0,0. 0,0. 0,0 is here in the origin. And 0,0 belong to the solution? Yes. It's inside the solution. Okay, one arbitrary testing point. And suppose another point outside, for example, 3,3. 3,3. Separated by a comma, 3,3. Bang, is outside the solution. It's obvious, and you mathematically, arithmetically, you can plug it into the inequality and verification, que es true statement, because 0 plus 0 is 0, and 0 is less than 4. And the other scenario is 3, 9 plus 9 is 18, 18 is no less than 4, it's greater than 4. It's trivial, it's elementary kindergarten idea. Yes or no? Everyone follow me or totally lost? Okay, cool. This is the idea. So now I want to complicate more, of course. Okay, suppose now in Desmos, we come back to Desmos again. This was example 2. What about example 3? Look at that. Example 3 is similar, but it's x squared plus y squared greater than 4. What do you think? Again, it's a circle. The center is in the origin 0,0 and the radius 2. But this circle I draw using solid line or dotted line? Help me. I need help. I need help. Dotted outside. Very well, Giselle. Giselle say, is outside and the boundary don't belong to the solution is dotted. Cool. You are the best. You are the best. You are the best. Everyone follow me? Everyone understand this elementary example? Huh? No? Confusing? Okay. Jose is a dotted. And you understand, Jose, is outside the circle?
Yes.
Okay. Let me complicate a little bit your life. Suppose this example. Let me try to modification a little bit, and little by little, I want to explain the basic idea. Look, we have two inequality. Now it's existing, not only once. 2, 3, 4, 5. How we are doing this? Easy. Let me try to copy. Control X, que es cut. Control B, que es page. Pero without curly bracket, no curly bracket anymore. Okay, cool. So now this is a line. This is another line. You plot that. Okay, for example, the first one I shape in black color, no? And the second, let me try to use in the same color, because in my opinion is better. I put a blue, no, same color, I put black. And you see that the solution, que es the intersection between this and this, is the part you see darkness. So this is like a gray color, no, and black, strong black is the solution because it's the intersection. Make sense? Make sense? Giselle. But Giselle, I want to explain one fantastic way. It's the way you want that you are doing in your test. Look, let me go back. Well, no, go back. I want to copy this. Control X. Entonces now you open. I close this. I open one in my keyboard, physical keyboard. I open the curly bracket, and you paste. Of course, don't forget to close. Pero automática Desmo que es smart, close. So when you open one parenthesis, curly or bracket or circular or curly, I close that. And now, what is the interpretation that? The interpretation is that Desmo is doing the intersection between these two inequalities. And the solution is exactly the same, but more elegant. The part that you see before, when you put separately the inequality and you see the darkness part is the solution, no? But you see only, so in one, I recommend this way because in some complicated example, entonces it's super hard to understand very well what is the solution. No, you have one inequality, two inequality, three inequality, four inequality. Wow, what the hell? I don't know. Entonces, doing by hand maybe is a little bit confusing. However, doing in this way is fantastic, easy, and nice. Do you understand this new idea? So the new idea I present is that you don't copy the system separately, inequality by inequality in different line. No, you put inside. Suppose you have another three inequality. I promise you see now three inequality. Entonces you connecting every inequality using curly bracket. So the third one, you put another curly bracket and copy the inequality. Do you understand the idea or no? Okay. Suppose the example 4, example 4, no, example 5. Suppose the example 5. In the example 5, we have two inequality, but I want to include one more. So x minus y greater than or equal minus 2. I want to include another. To include another is easy. Is you put a curly bracket, and you put a y. Let me use on the keyboard for decimals because it's easier. Y greater than 5. So actually, in this moment, I try to do one system that contains three inequalities. One, the first one is y less than or equal minus x squared plus 4, que absolutely is non-linear, es parábola. And two more, que they are linear, x minus y greater than or equal minus 2, and another que es y greater than 5. And I want to see the solution of this system. Okay, you activate this, bam. Let me see what's going on. Hey, what happened? Something not good. Let me try activate this. Maybe, yeah. Okay. I don't know why, sometimes doesn't work very well. Maybe you put inside here another bracket. Let me try it in this way. Y greater than 5. Greater than 5 or greater than negative 5. This was the mistake. I put negative 5. Negative 5. Bang! No. I suppose que no. The mistake was at the beginning was que I put positive 5, not negative 5. Let me try in the traditional way. The traditional way is you open again another curly bracket and you put a y less than or greater than, sorry, if negative 5. Negative 5. And you see the region solution is this. Okay, it's formed by, let me break it down in different pieces. The first piece is, okay, I select this, Control X. Oh, it's a parabola. es obvio que es solid. Because it's equal. And it's obvious also que es inside the parabola because it's less than, no? See, I incorporate to the system of inequality one more, suppose this, Control B, pero no two, sino one more. Okay, entonces now, I suppose que that part x minus y equal to is a line passing through this point. Y es greater than, but actually when you isolate the y, it's less than. Because somehow, in one moment of the algebra, I need to divide by -1 to say it's less than. And finally, si yo incluyo the last inequality, okay, entonces now this is a horizontal line, horizontal passing through -5, and this is above this line. So basically, my region is formed by one piece of parabola, one piece of the line, and another piece of the another line. Okay, do you understand very well or no? I have an opinion. It's important to understand. I think I understand. Okay, it's important that you understand that when you have a system of inequality, so you have several inequalities inside one system, the logical operation in between the inequalities and means intersection. So you need to find the one value or a bunch of value or region can satisfy the first one and the second and the third inequality. And so on. See, we have more than 3. So it's intersection, not or. Okay, or is union, no intersection. Do you want to see another example? I have another more complicated example. Let me try to find one super complicated example for you. But you don't worry, because we are doing using decimals. Because after that is the good part I want to show you. No? Let me try to find another system of inequality. Example 1, example 2. Let me see. Yeah, I like this. So you continue doing watching the decimal, right? In this case, we have 4 inequalities. The first inequality is 3x plus y less than or equal to 6. The second is 2x minus y less than or equal to -1. The second is x greater than -2. And the last one is y less than 4. And you put everything together. Separate by curly bracket. So now when they activate, bam, this is the solution. So basically, this is the central idea I want to explain now. Look, you have linear because it's linear. So every inequality in this case is linear. So you see the exponent is 1, no 2, no 3, no square root, no, it's linear. So normally when you are doing the solution of the system of linear inequality, normally, no 100%, but the majority of the time, you obtain polygon. Actually, in this case, you take polygon quadrilateral, 1, 2, 3, and 4 sides. And the region inside is the solution. And the region outside. Okay? Do you understand very well this? Tell me, guys. Say, you understand or no? Because I want to explain that now, the complicated part. Okay, let me come back to the whiteboard. Okay, whiteboard. Switching, stop, switching, whiteboard. Okay, do you see my whiteboard or not yet?
Yeah, we see.
Okay. Now, so you understand a little bit, we need to practice, of course. But conceptually, you understand the idea behind. the linear system of inequality, I want to explain one important branch of the mathematics que es called linear programming. Linear programming. Programming. Double M. Programming, ing. Linear programming. Linear programming, guys, is super useful to understand the optimization problems. So the optimization problems, problem in business and whatever application means obtain the best solution. You need to obtain the best solution. Best solution. You need to obtain the best solution depending the nature of our problem. Maybe it's a maximum. For example, si it's the profit, you obtain the maximum profit, or sometimes it's good the minimum. For example, si our problem involves the cost of the production and the manufacturing, I would like the best solution is obtain the minimum cost. Another application. So, our optimization problems contain two pieces. The piece number one is the constraints. Constraint is formed mathematically by the collection of the system of inequality. Suppose the example one, to illustrate the idea behind this. Example one. In the example one, the constraint is x greater than or equal 0, y greater than or equal 0, x plus y less than or equal 60, and y greater than 2x. Wow. 1, 2, 3, 4 inequality connecting by system. It's a one piece, always in the typical optimization problem. And we have another equation, que is the objective equation. Objective function is more proper name. I don't know why. Normally it's called Z, capital Z, the dependent variable, and depending of the x and y. For example, 250x plus 150y. And that's it. No, I need the specification, the thing you want to maximize. Suppose maximize. Like that. Okay. So what is the idea? The idea is, I want to explain it now. Look, first of all, I go to the Desmos, and I solving this linear system of inequality, and you get, I don't know, one parallelogram, one polygon. However, I finish, and this is the feasible region. This is region que satisfy the inequality as a feasible region. That means any point here, bam, satisfy perfectly the inequality part. However, I need to find the maximum to satisfy the objective function. The objective function is a line. And the line z equal one number, suppose 200. Suppose the same line, pero, so the same slope, pero C equal 150, is moving here, or moving here, moving in that direction or in that direction. And that direction have no sense because it's totally far away. The feasible ratio, guess the part makes sense according to my problem. This is the thing is available. I promise, guys, after I want to explain the word problem, to illustrate very well, because in the Alex homework you see the word problem of the linear programming. And the test, no, don't worry. Yeah, you see linear programming, but no when the word problem, because the word problem is confusing. No, some people say I don't understand very well the word problem. You need to read, you need to dedicate too much time thinking about the inequality. No, don't worry for this. The problem is that in order to optimization, will always happen that the maximum or the minimum occur in the corner of the feasible region. In this case, in this scenario, I want to show you in detail now. Suppose you touch this corner, and this is maybe C equal 100. Wow, nice. So now, and this is okay, and this is okay, and this is okay, but the value is maybe it's 80, is 70, que es no maximum, y I need the maximum. And the maximum is always in the corner of the feasible region, que normally is a polygon. Okay, entonces es super easy. Look like long, complicated? No. You have the typical linear programming probably contain two pieces. The constraints, the constraint is probably the availability of the product of the time that you have to available to do something. So this is a limitation of it's a constraints. Now I need to optimization, maximize or minimize another function, que maybe it's a money, or maybe yes, it's a money, but profit or cost, depending, no, si es maximize or minimize. Entonces I need to, matching this idea with this idea. And the maximum or minimum always happen in the corner of the polygon. And what should I do? Well, I have no idea. I determine the corner. I evaluate. You are doing the table. In the table, you evaluate. And this, suppose hypothetical. In this corner, x is equal 20, y is equal 40. And you plug in that value into the objective function, and you get the one value. And one by one, you are doing the corner 1, and the corner 2, and the corner 3, and the corner 4. And you select bang, the maximum occur in the corner, I don't know, 1, maybe. Let's see. So you get the big picture. Now let's do a specific example. I try to find decimal. I bring one example. Nice. I bring so several examples. Look. Linear programming. Oh, yeah, no. Okay. Linear programming. Okay. Boom. Okay. In this moment, of course, you see the whiteboard, no? I want to switch into decimals to illustrate very well this idea. Look, switching to decimals. Do you see now my decimals?
Yes.
Do you see? Okay, cool. Look, let me open example 1. Example 1 is, you can copy in your notebook. The constraints is this system of inequality. Que es easy, es x greater than or equal 0, y greater than or equal 0, x plus y less than or equal 60, and y greater than or equal to x. And you type in this tiki, inequality by inequality, separate by curly bracket, because you remember very well that curly bracket means and you, when you do the graphic of this, bang, you get only, the gray part. And this is my feasible region. In this case, it's a triangle. And the triangle have three vertices, three corners. And you evaluate the objective function. Okay, by the way, the objective function is 250x plus 150y. Evaluate at the corner 0, 0, okay, obviously is 0, and you evaluate in 2040, okay, it's one number that I don't know, but I want to find right now, and 0, 60, okay? So now, in this most I did in that way, but in the real life, this is enough. Can you determine this 20, 40, 0, 60, and 0, 0? I illustrate this idea. Look, this is my objective function. So this line in blue color represent the objective function. Entonces en this case es 40,000. 40,000 I suppose que es money, $14,000. And here, this is totally outside the feasible region. Oh, this is inside. Good. I am happy inside because of the availability. I need to satisfy that condition. But the best scenario happen here in the corner 2040. In 2040, the objective function value is 11,000. And you find the maximum. End the story. I want to show you more. I want to show you more. Look. Do you follow me? Yes or no? Okay. Opinion, guy. Opinion. Okay, let me go back to the whiteboard because I want to explain or summarize a little bit the basic idea. Do you see my whiteboard now? You see or no? Okay. Yes. Look, Giselle. This is my rectangular coordinate system. I want to do roughly, no accuracy. X, Y. I using decimals, I determine one line like that, one line like that. This is my feasible region. That means inside the feasible region is okay. I am fixed according to the limitation of the problem. So immediately I determine that corner, and that corner. That corner is obvious 0, 0. That corner was 20,40. That corner was 0,60. Yeah, I do the table like that, in which you put X, Y, and Z. So now you evaluate in 0, 0, okay, this point. You evaluate in 2040, okay, this point. And you evaluate in 0, 60, okay, is the last corner. That's it. The rest of the point is okay, it's inside the feasible, it's matching perfectly, but no, it's not the optimum, and no maximum or minimum. Entonces now I know the formula que connecting C is 10250x plus 150y is equal to Z. Es obvio que si yo evalúo Z at 0, 0, es obvio que es 0. You put this 0 here. It's no maximum, it's nothing. However, si yo evalúo Z in 2040 is 250 multiplication by 20 plus 150 multiplication by 40, and you put in a calculator, and the answer was 11,000. I don't know if it's money or whatever, I don't know. It's another problem now. After I see what problem and we solving completely the idea. And finally, you are evaluating 0,60. So it's 250 times 0 because X value is 0 plus 150 multiplication by 60, and the answer is 9,000. 9,000. It's obvious that the maximum is here. It's the optimum maximum. So now, sorry, you complete the table. It's 11,000 and 9,000. This is the maximum. What is my final answer in this linear programming problem? Well, the final answer is the maximum is equal 11,000 at, let me use in English, at x equal 20 and y equal 40. End the story. This is my final answer. Okay? Okay. Do you want to see another? Another about the minimum, for example?
Yes, yes.
But do you understand a little bit the essential idea? Of course, you need to do at least one in your life. Entonces, I propose one fantastic idea. I have a PowerPoint. Okay, I want to send to you. Entonces, totally optional, guys. No problema. The PowerPoint contain extra example. It's 8 extra example. If you want to do one example, so one example is extra point is 5 point extra. So you are doing 2, 10, and so on. So you are doing 8, you have 40 extra. That's an extra credit. The student need to improve because in the first test are doing not too well, and you pretending to get A in that class. Try to do the word problem. Of course, the solution you send me attached to the test, and the due date is the same day. No? It's the famous June 16. June 16, you send me the test. You send me one, professor, I try to do at least 2. Okay, so you're doing well, it's 10 extra point. Okay, you understand the idea? Okay, so let's do one more example of the linear programming. I'll try to come back to the decimals part. Please try. Okay, switching to decimals. Okay, in these decimals, I try. Look, you see the table? X, Y, and Z. Do you see? And the first program, of course. Do you see it, right? Okay, forget about example 1. I propose you see example 3. Why 3? Because it's a minimum. Because 2 is similar, maximum. The most popular is maximum, but sometimes minimum. Minimum. Okay, I like that. Because in this case, the problem is given in the constraints, is this system of inequality. You copy now horizontal, you copy vertical. X greater than or equal 0. X, Y greater than or equal 0. 2x plus y greater than or equal 8. And 2x plus 3y less than or equal 2. And this is my constraint system, que es 1, 2, 3, 4 inequality, and we're connecting by curly bracket because it's AND. You need to find the bunch of values, the region, que satisfy this. Okay, let me try. Look, I make it zoom to see more clear. Oh, look at that. The solution is a triangle again. The triangle again. Now, the corner of this triangle is 3,2, 4,0, and 6,0. And when you finish that part, and you determine the corner, of course, I put for everything together easier. Because how you determine the corner? Well, you simultaneously the equations, and you solve the the equation, no? Because actually in the corner is equation, equal sign. Now I evaluate in each corner, you evaluate 3,2, the answer is 12, and 6,0, the answer is 12. And make it sense que es 12 because look, it's the same line. In this moment it's 12, C value. However, I need to find the minimum, so I go, continue down, and when you reach 4,0, the answer is 8, que es the minimum. So in this problem, you can see que our problem, the solution optimal minimum, porque I don't know si es a cost, is 8 something, $8 million. And occur when you set up x equal 4 and y equal 0. That's the main. Okay, so now I suppose you have 1,000 questions in the air, but I want to clarify now. Let's move on. I propose you now moving to the whiteboard again. Let me try to make one completely word problem of the linear programming. Okay, let me try. Let me try linear programming. It's no big deal. There's more name than the design behind this. Look. Oh yeah, I have this word problem. Let me see, where is this? There you go. I bring one picture of my PowerPoint. Look, this is a typical business problem in which you can apply linear program. For the given week, Donna's Coffee House, it's a manufacturer, has available 1,792 ounces of A. What is A? It's a grade A coffee. So we have two kinds of coffee. The table below illustrates much better this idea. But the availability of the coffee A is 1,792 ounces. Okay, it's a limitation, it's a constraint. And 1,600 ounces of the coffee, grade B, grade coffee. Okay. Now the problem is I want to mix this coffee in two categories: economy blend and superior blend. Of course, the price of the economy is $2, the package. The superior is 3 because it's better, no? And to mix it to create economy or superior, depending of the coffee grade A or coffee grade B. So the formula for the coffee economic is put only 4 ounces of the grade A and 10 of the grade B. It's a formula. And the superior, no. Superior is 8 of the grade A, que suppose gets better coffee, and 2 of the grade B. This is the formula. So now, what is the idea? The idea is using this information, try to planning the best strategy to manufacture the coffee. How many economy, how many superior I need to manufacture in order to get the maximum profit, maximum money. Do you understand the idea? The solution is coming now. But the idea of the setup of the problem, do you understand or no? Okay, let me try. So I see okay, we have 1,792 ounces of coffee A, no? Coffee A, grade A. It's a one availability. And we have also 1600 ounce of coffee B. This is our availability. And this is a limitation. It's a limitation to say maybe I cannot get $1 million because I have a limitation. However, to form the economic formula, economic blend, or whatever you want to call, we mix it 4 of these, 4 ounce, and 10 of these. 10. Okay, to get, of course, 14 ounce of this economic, que I suppose que is this package, economic. Okay, now to get superior, the formula is different. Superior, well, the formula is you take 8 ounce of this, and 2 ounce, 2 ounce, to get, of course, 10 ounce. You see that the weight of this packet is less than this. However, the price is $3 and the price of this is $2. I suppose it's very, very optimum to sell a lot of quantity of superior, but depending on the customer. The customer, no, I want economic. Okay, I respect idea. Okay, this is the idea I try to create, guys, as always happen in the word problem. You create one, diagram to illustrate much better how behave the word problem, blah, 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 to understand this. So now, suppose I create one inequality of the coffee A. So in this inequality, I want to focus in this coffee. This coffee, sorry, is taking 4 ounces of X. And who is X and Y? Well, X and Y, I suppose that X is the packet economic that I produce, and Y is the superior that I produce, no? So now, see, I focus 100% only in the coffee A. So this equation is coffee A. Of course, we have another equation that is coffee B. But forget about B for a moment. It's 4X plus AY, because A also with the decay as superior, is less than or equal 1792, que is the availability of the coffee A. Likewise, 10X, because we dedicate 10 ounce here, plus 2Y less than or equal 1600. Okay, and this is my inequality. Okay, actually, let me try to set out the constraints properly. Nice constraints of this word problem. Constraints is 4X plus AY less than or equal 1792. Another constraint is 10X plus 2Y less than or equal 1600. Of course, always when you working with the physical situation, this value must be positive, not negative. So one solution in the second quadrant, third quadrant, and fourth quadrant is totally illogical. my solution is lie in the first quadrant because every quantity is positive. Coffee is positive, packet is positive, everything is positive. Okay, and this is my y, sorry, greater than equal to. And this is my constraints, que consiste, I repeat one more time, system of inequality. Cool. Now the objective function. Objective function. Objective function. Well, objective function is CC, is Z. C equal, what is the price? What is the price? I don't remember. Oh, the price is $2. So this is 2 represent money, $2 multiplication by X, que is the amount of package that you produce, plus $3 multiplication by Y. I have my problem. I have the setup of our linear programming problem, que consists in 2 pieces. The constraint que represent the limitation of the problem, and the objective function que represent the objective function that I want to optimize, in this case, maximize, because I want to obtain maximum money. Okay, now ready, almost ready. Now the complicated part, you don't worry too much. I go to the decimals. Let me try to find. Linear programming problems, no? Linear programming problems. Linear programming. Okay, let me try. Typing linear programming problems. Approximation. Oh, problem, no, I don't know, problem. Let me try to find problems. Oh, there you go, linear programming problem. In this case, I suppose this is the last problem. Yeah, absolutely. Don't worry, guys, I found. Now, I try to switch into decimals now. Switch into decimals now. Do you see decimals? Do you see my decimals now? Do you see my decimals now? Yes or no?
Yes, please. Yes, please.
Yes. Yes. Now I copy my system of inequality. Is this guy? Copy one by one, separate by curly bracket. For x plus ay is equal to something. 10x plus 2y less than or equal to something. X positive or 0 or y positive or 0. I plot that. Boom. Wow, what the hell? The problem is that the number is too big, no? And you get this feasible ratio. Okay. If you want, I can separate into the several pieces, but not necessary, because I know that that's more fantastic solving the linear of inequality. This is my feasible ratio. So my solution is inside or in the corner. I suppose in the corner, right? I create a table for the feasible region. However, to illustrate the idea graphically, to see more clear, in my opinion, is I put equation of the objective function in green color. Yeah, moving. This is totally outside the feasible region? No, have no sense, stupid. Our inside, yes, but what is the optimum? The optimum is in the corner. Maybe we have this corner, this corner, this corner, or this corner. 0, 0. 0, 0 is relatively trivial. It's 0 money. Look at that in the table. 0, 0 is 0. And 0 in that corner, que es 0,225, is $675. I plug it in directly here. Okay, not bad. And this corner, que es 160,0 is 320. No maximum. And this corner, yeah, it is approximately $736. According to the availability, what is the final answer? According to the availability we have, well, our maximum profit is 736. And for this, I need to manufacture 125 package of the economic blend and 160 is logical of the superior. So the final answer is, I want to repeat again. If you, according to this availability, is the feasible region, que es the region que hay highlight ahí en red color, actually pink color. Okay, our maximum profit occur at the corner, que es 128,160. 160. What is the interpretation? Well, the interpretation is when you produce, you manufacture 128 package of the economic coffee and 160 of the superior, you obtain $736. It's not too much because our availability is not too much, and the coffee is very, very economic, $2 and $3. But suppose that you can extrapolate this to the million and you get the business. Do you understand very well the idea, guys? Entonces now I want to do something. In the next video that I will send to you, I included the PowerPoint. The PowerPoint have 8 problems. 8 problems. So now, so you have time and you want to improve your grade, or you want to get superior students, why don't you read and you try? The idea is very, very easy. The idea is you take the inequality, you put in decimals, you watching, using your eyes, the feasible region, and you determine the corner, tac, 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 and you evaluate the objective function in each corner. And you obtain, depending on the problem, sometimes it's a maximum, sometimes it's a minimum. Okay? Do you follow me? Do you understand the idea or no? Yeah. Okay, it's a challenge. So I detecting the good student and the not good student, the lazy students. Okay, so now we start review. And the time we have 20 minutes, 25 minutes. We start doing the review, que is super easy, in my opinion. Okay, I want to come back again to the whiteboard, but I want to erase the whiteboard completed. Okay, cool. Share whiteboard. Switching, whiteboard. Okay. Do you see my whiteboard? Let me try to do my best. Question 1 in the review package. It's super easy. Okay, let me try to find. There you go. We have 2 equations, x plus y equal -9, equation 1, and x minus y equal 1, positive 1, equation 2. This is the system. And the equations say, very, very important, this area I want to discuss it now, is verify. Verify who? Verify one hypothetical solution that's given in the problem, and you need to verify. So when you verify, you don't need to solve it. You can, of course, and compare the solution that you obtain and the solution that's given to verify. But no. In this case, I recommend, if you want to verify, get -4, x is equal to -4, and y is equal -5, you verify. Verify is easy because you take equation by equation. For example, you take equation 1. Entonces you replace x is -4 plus and y is -5. Should be -9. Yeah, I claim that, question mark. It's obvious it's true because -4 and plus and minus together and minus is equal to -9 is true. It's true. It's true. But must be true in both equations. Remember, this is and. So the logical connection in between the equation and the inequality is always and. Entonces, the equation 2, let's try to do exactly the same. It's -4 minus -5. Should be 1. Well. In this case, no idea. -4. Negative and negative positive 5 is 5 minus 4 is 1. Okay, it's true. See, both are true. Then the answer is yes. Is the option A. Yes, this solution gets given at the beginning, matching perfectly with the both equations. Therefore, the answer is yes, a solution. It is solution. Any question? Do you follow me? No. Okay, cool. Okay. One question like that you can see in the test. Similar. Let's practice another. Number 2. Number 2 say x plus y equals 0, equation 1, and x minus y equal -12, equation 2. Clear, Giselle. And the answer solution, sorry, I want to verify is x is 6 and y is 6. Okay, equation by equation. Equation 1. In equation 1, 6 plus 6 is equal to 0. Oh, no. This is completely false. Because 6 plus 6 is 12, no 0. Therefore, this solution que somebody, I don't know who, proposed me at the beginning doesn't work. And this is it. Cool? Okay, let's move into the question 3. Question 3 is no verify. Let's solve it. And you have a system in 2 dimensions, nice. 2x plus 63y equals 63. This is equation 1. And 7x minus 9y equal -9. Equation 2. Okay, there are many ways. Not infinity, but there are many ways. I don't know exactly what do you pretend to see. In my paper, I did that way. I take the question number 2 and multiplication this equation 2 times -1. What was my intention? My intention was elimination. Remember, a -1 times 7 is -7. You have 7, but positive, and I convert it to positive negative. So when you multiply the entire equation 2 by -1, we have minus 7x plus 9y equal positive 9. And this is exactly the same of the original equation 2. However, I want to focus in this equation and this equation. And you adding equation 1 plus a new equation 2, that by the way is equivalent to equation 2 original. And this is canceled. This was the intention. This is 72y equals 72 because it's the same number, 63 plus 9. Divided by 72 both sides. Y. I feel it. No, I need to find both x and y. Therefore, to find the x value, I pick arbitrary. I pick. Exactly. You're right. Because let me finish. I take, for example, the equation 2. I don't know why I like this. I suppose it because it's easy. Entonces you plug in 7x minus 9 times 1, que y es 1, equal negative 9. 7x minus 9 equal negative 9. 7x is equal minus 9 plus 9 is 0. Divided by 7 both sides is obviously 0. Therefore, the solution of our system is located at the point 0, 1, que es the option A again. Okay?
Professor.
Go ahead.
Did you change equation 2 so that you could get rid of the x?
Say again, Mister. I don't understand very well your idea.
I wanted to clarify that you changed equation 2 to negative so that you could get rid of the x, right?
That was the intention. There another possibility, yes. Suppose that you make a decision, Mister, multiplication, the equation 2 again by 7, positive 7. What is the idea? The 7 times 9 is 63, and you have 63 positive and 63 negative, and you eliminate the y. I guarantee you that either way that you are doing, if you are doing well, you get the same answer. Okay? Do you understand very well my explanation?
Yes.
Okay. Let's move into the question 4. Question 4. Question 4 say 6x plus 3y equal 51. I like so much call each equation by number 1, 2, 3, 4. And you see the importance of this in next chapter. 2x. Next chapter we continue working with the linear equation, but in another way, more powerful. 2x minus 6y equal 38. This is my system. 2 equation, 2 unknown, 2 dimension. Okay. Well, no idea. Well, I have idea, yes. I take advantage that this guy is positive and this guy is negative. Entonces, in my opinion, it's better elimination the y. How? Well, you multiply by 2. So using this idea, guy, you put a box and put a time symbol and multiply by 2. When you multiply the entire equation 1 by 2, we get 12. 12x, so 2 times 6 is 12. 2 times 3 is 6y equal 102. Get the multiplication 51 times 2. And this is my new equation 1. Nice. Okay. Now my system will focus in this and this equation. When you add in equation 1 plus equation 2, we have 14. The 6 is canceled. That was the intention at the beginning. And we have 140, que es 102 plus 38. But about 14 both sides. It's over the 10. X equal 10. We're going to find the y value. You decide. Pero I'm smart. I take the easier equation, que in my opinion is this one. Entonces, you substitution x for 10. Entonces, you have 2 times 10 minus 6y equal 38. Oh, this is 20. Minus 6y equal 38. Minus 6y is equal 38 minus 20, que es 18. entonces minus 6y is equal to 18 divided by negative 6 both sides. Y is equal to minus 3. Therefore, my solution is the order pair 10, minus 3. Again, is the option A in our handout. Cool? Everyone follow me? No problema? Okay, the first two questions in the written test is verify and solving linear system, but in 2D, no in 3D, 3D after. But at least you have 2 questions. In total is 14 questions, I guess. I want to erase the board, guys. Question 5. Oh, question 5 is 3 dimensions. Okay, no problem. Question 5. Question 5 say. Question 5 say. Let me see question 5. Question 5 is. Oh, look. X plus Y plus Z equal 4. This is my first equation. X minus Y plus 5Z equal 12. And 3x plus y plus c equal 2. Okay, we have 3 equations and 3 unknown. Typical 3-dimensional problem. But in this example, I don't need to solve it. No. I need to verify. Verify hypothetical solution que es given, que es x equal positive 3, y equal in positive 2, and z equal negative 1. I plug it in one by one. Slow down, guys. Relax. And you verify. You verify in the equation 1. In the equation 1, we have 3 plus 2 plus negative 1 should be 4. It's obvious it's true, because 3 plus 2 is 5, minus 1 is 4. Okay, true statement. Therefore, no problem with the first. Equation 2. To be solution of the system is to be true in every 1, 2, and 3. See, at least one fail, no. It's no solution. So in the equation 2, we have 3 minus 2 plus 5 times negative 1 should be, I claim that question mark 12. 3 minus 2 minus 5 plus and minus and minus should be 12. So you can, for example, you combine the negative number together. There are many ways from left to right. Addition, subtraction is pretty easy. It's 3 minus 7 should be 12. You put together this guy. It's over the negative 4. Negative 4 is equal to unknown. It's not true. It's completely false. Therefore, this solution doesn't match it with this. And that's it. I don't want to find the solution. So the question no is find the original solution. The system of no, a verification. See the solution gets given is correct or incorrect. End the story. Any question? So far, you see that the test is easy, eh? What do you think? Are you tired? I need to hear opinion. So far, it's okay. So far, everyone have 100 points in the test. You have to study. So it's Jose says so far. So far. Okay. Let's move on to question 6. So far, Jose says so far. Question 6. Well, question 6 is. Go ahead.
How do you know which equations to put together?
How do you know? Put together. What put together? Okay, this system meter is given. This solution is given. And my goal is verification, see this solution matching in this system. And you plug in one by one equation and you verification, true statement, true statement, true statement, true statement. See at least one a false statement, no solution. I don't know if it's your question, no? Let me know.
So if there's one false statement, the entire question is false.
Yes, you're right. See, at least one is false. Entonces now we have in the wrong solution. This is not correct solution because the correct solution is the solution that satisfies every equation one by one. True, true, and true. This is the chart. Come on, I hear something. Everything okay or no? My explanation,
yes.
My explanation was clear or no?
Yes.
Okay, continue. Okay, number 6 is nice. Sx plus 4y plus 2c equal 3. This is my first equation. My second equation is 5y plus 3c equal 4. And my last equation, wow, it's too easy, is z equal minus 2, equation 3. And this is the system. What's the problem in this system? Well, the problem in this system is, okay, for example, in the second equation, the x part is missing. In the third equation, the x is missing and the y is missing. And of course, I take advantage of this idea. Okay, so I take advantage to apply back substitution. What means back substitution? Well, I can see, using my eyes, can see s equal minus 2. Taking this equation, in which you have no y, no x. And you back substitution, plugging in c equal minus 2 in the second equation. So my second equation is 5y plus 3 times negative 2 is equal 4. 5y minus 6 because positive 3 and times negative 2 is minus 6 equal 4. 5y is equal 4 plus 6. I'm moving to the right hand side. 6 is 10 combined and divided by 5 both sides. y2. Entonces y2. C is negative 2. Sorry, I forgot to enclose in the box because it's important information. And using C negative 2 and Y positive 2, I plug in that value in the first equation, in which the only unknown is X. So I copy again the equation. Plugging in, substitution. X plus 4 times 2, because y is 2, plus 2 times negative 2 is z, negative 2. Should be 3. X plus 8 minus 4 equal 3. 8 minus 4 is 4. X is equal 3 minus 4 is negative 1. Okay, now my solution is the triplet order. Negative 1, comma, positive 2, comma, negative 2. Remember, this is the order. X is the first component. Y is the second component. Z is the last component. This is the convention. Again, one more time, the solution is the option A. Super cool. We have time to one more. We have time to one more. Because the other is really, really stupid. Guy, you follow me? Do you understand very well the idea behind back substitution? We're using in the next chapter. back substitution. Because this system is special. This system is like expressed in echelon. Echelon form. What mean echelon? Can look like stairs. Look, we have a hole here. We have another hole here. Stairs. This is missing. This is missing. This is missing. It's an echelon. So when you, it's a one super fantastic strategy for solving the system. You know, try to move in, try to convert in echelon form. But this is the next chapter, chapter 3. Okay, one more question and that's it, because the time is almost over. Question 7. Question 7 is super easy. Look at that. Look at that. Only you need to use your imagination. Suppose, again, x plus y plus c equal 10. This is my equation 1. X minus y plus 3c equal 14. Equation 2. And 2x plus 2y plus 2c equal 6. Equation 2. Entonces, I put intentionally this example because automatically you try to take two equations and pair each equation and eliminate one variable. No. You dedicate at least 5 seconds to inspect. Take a look. The equation. Yeah, I discovered something. Wow, look at that. The coefficients is even, and even. And there are no reason to write like that. Maybe most better x plus y plus c equal 3. Yes or no? This equation is equivalent to equation 2, right? But I see contradiction because in the first equation you see x plus y plus c equal 10. In the last equation you see x plus y plus c equal 3. And this is impossible because this expression is equal 10 or is equal 3, but not both. This is typical without do anything, no solution. So you try, suppose that you don't see this, no problem. You apply the systematic way. You take into equation pair, eliminate y, for example, and take another, eliminate y, the same variable. And you, after you put together, eliminate x or eliminate z, and you get no solution. Okay, but you take a look, because in the test I put intentionally complicated system, que apparently look like complicated, however, it's a piece of cake. Do you understand the basic idea que es no solution or no? Do you understand? Cool. Okay, guys. So now, remember, in a few minutes, I will send the 3 things. Number 1, the video of this class. Number 2, the video of the review solutions. And number 3, the PowerPoint for the extra credit. Okay? This is totally optional, only for a student that want to get good grade with me. Take advantage. Okay? Bye-bye. Have a nice day.
Oh, sir. Have a good day.
You too.